Hello my dear viewers and my lovely students. Welcome to my math distance learning session. Today we have another yet important video for grade 11 and 12 students, and the lesson for today is higher order derivatives. So let's get started. In today's class we will be learning how to find the derivatives of higher order, and we'll be also solving some important AP calculus questions on this topic of higher order derivatives. This is a must-watch video. Please watch it till the end. Solve the questions that I give towards the end of the video for testing your understanding, and then you can post in the comment section if you have any further queries from this topic. Let me give you an understanding of the concept of higher order derivatives. So till now in the previous videos you have seen how we can find the first order derivative or the first derivative. So generally we denote the first derivative by the notation f prime. And how do we get this f prime? If we differentiate the function which is given to you. So here the function is fx. So when we differentiate fx with respect to x, now the order of the derivative would decide how many times we are differentiating. So because we are calculating here the first order derivative, so we are going to differentiate it only one time. So that will give you your y prime or f prime x, and here because your fx was a polynomial function, so we will apply power rule to get the derivative. So the derivative of x to the power 5 is 5x to the power 4. The derivative of negative 3x to the power 4 becomes negative 12x cubed and plus 1. So let me remind you a little bit about power rule. So if you differentiate x to the power n, then power rule says that the power comes down and the variable x will get reduced by 1 in the power. So this is your power rule. We've used it so many times and I'm quite sure now you have learned the way we have to use it. So this was your first derivative. And if you know that we can also go ahead and do it or differentiate it another time. So when we now differentiate f prime x once more, then what we are going to be getting? We are going to be getting y prime or y double prime, I would say, because the number of times we are doing the derivative would denote these number of powers that we are putting here. So y double prime will be equal to f double prime, and this you are going to get when you differentiate d by dx now your first derivative. So 5x to the power 4 minus 12x to the power 3 plus 1. So let's see in the next slide what does the second order derivative come out to. Let's see what is the value of f double prime. Now we are going to be finding the second order derivative. So your second order derivative is denoted by the notation f double prime of x, and as I have explained you in the last slide that you get this derivative by differentiating the first order derivative one more time with respect to x. So your notation for f double prime will be equal to the first order derivative f prime and then its derivative. So let's see what we get. Now your y was f, which was this function. You had got f double prime, which is going to be d by dx of 5x to the power 4 minus 12x to the power 3 plus 1. So this was your first derivative. I'm just substituting. Again, this is also a polynomial function, so we can go for power rule. So the derivative here will be 4 will come down, power reduces by 1, 3 will come down, power reduces by 1 again. 1 is a constant, so it will get removed. And further you can see after simplifying that this comes out to be 20x to the power 3 minus 36x to the power 2. So this is your second order derivative. So this is how we can continue this process to get the higher and higher order derivative. And now you would just see in the next slide that if we are going to differentiate one more time, what we are going to be getting is the third order derivative. So let's try and find that also. Okay, so if you continue the process of differentiating one more time the previous derivative, then similarly you will be getting the third order derivative. This is the third order. Then you can similarly go on, continue the process, get the fourth order derivative, fifth order derivative, and so on. Now for this given function fx, which was given to you in the beginning, after you see your fifth derivative, your sixth derivative onwards would come out to be 0. So there is no need to find the higher derivatives after you are done with the fifth derivative. And another important point that you would have observed here is that this process of finding the higher order derivative, it is very dependent on the last derivative that you have found. So to avoid any sort of error or any mistakes, you should be doing your differentiation very carefully using the right rules. Now here, when notation like f, you are putting so many primes at the top, it becomes quite lengthy. Then we can put it in the form of f to the power nx, where n is denoting the number of times you are doing the derivative. So for example, if you want to write your fifth derivative, so here n is 5. So you can just replace, instead of drawing those primes on the top so many times, you can write f5x. So you know that this is the fifth order derivative. So that's a different notation, much easier to use. We are ready to summarize the concept that we have seen for the higher order derivative through the example of the function y equal to fx that we started with, that was x to the power 5 minus 3x to the power 4 plus x. So you can write your higher order derivatives f3x, f4x, f5x, f6x, and so on in this way. And then finally your fn x is going to be 0 for n greater than equal to 6. So this is how we can summarize the higher order derivatives. Let's now look at example 1 for today. So this example has the function y given to you. Again, as you see, it's a polynomial function. So let's try and find the first 5 derivatives for this function, because as you know, after the fifth derivative you are going to be getting eventually 0. So you are going to be using power rule to get the derivative. So you differentiate this function y one time and apply power rule. So your derivative, the first order derivative, I will write here f1x is dy by dx, which is equal to 5x to the power 4 minus 12x to the power 3 plus 1. Then your second order derivative, so you are going to differentiate 2 times. So d square y by dx square. So we are using different notations, but the method to reach to the derivative would be similar. So again, you are doing here to get the second derivative d by dx of the last derivative. So that's this one. So what happens? We apply power rule, 4 comes down, that gives you 20x cube. And then 3 comes down, it gives negative 36x to the power 2. Finally, for the next term, you have the third order derivative f3x, and you get this by doing the same process. So you differentiate 20x cube minus 36x square. Again, we are using power rule, 3 comes down, 60, power reduces by 1x square. Again, for the second term, your 2 comes down, 72, and reduces by 1. You continue the process till you reach to your fifth order derivative, and that is where we stop, because I know my fifth order derivative is a constant, which is 120. So when you are going to be differentiating that, it will give you 0 in the next step. So the sixth order derivative onwards, for this given function, the derivative is going to be 0. So this was one example on higher order derivative. Let's now solve an important multiple choice question that will help you for your AP calculus exam. So here you are given the function y as e to the power x cube, and you need to find the second order derivative. There are 4 options, so let's see which is the correct one. So to get the second order derivative, we need to differentiate 2 times. That is the hint from what we have learned today. So let's get started by differentiating it once. So we are finding now dy by dx, or you can say y prime, which is the first derivative. So d by dx of e to the power x cube. This is an exponential function, so when you are going to differentiate, it will give you the same function and the derivative of the power, which is x cube. So this d by dx of x cube, we can use power rule here, and when you are doing the power rule in this step, you will be getting this 3 coming down. So 3 e to the power x cube, and the power reduces by 1, so x square. So you've got your y prime, or the first order derivative. I'm marking this as the first equation. Now we are going to be continuing this process so that we get the second order derivative. So now we are differentiating one more time to get a d square y by dx square. So d by dx of the first derivative. Now if you observe carefully the first derivative, then here your 3 is just a constant. It can come out of the derivative, and this is a product of 2 terms, e to the power x cube and x square. So I'm sure you'll be able to recognize that we have to go for product rule to get the second order derivative. So let's continue to find the second order derivative, and I'm taking now 3 outside and d by dx of this product. So let's apply product rule. So what are you going to get? 3 times first function as it is, derivative of derivative of x square, that is 2x, plus x square as it is, derivative of e x to the power cube, so which is same as your first order derivative. So I'm just putting the value from there. Okay, so that completes the second order derivative, but we need to do some sort of rearrangement for this function so that we can look at the 4 option and identify which is the correct one. Now if you look at this function that we have received for d square y over dx square, we need to just simplify it a little bit more. So let's multiply, and if we see there is any term common, we are going to be taking it out. So I can very well see that e to the power x cube is one term which is going to be common. So we are going to be taking that term outside, and inside now I'm going to multiply both the terms which are inside the bracket with this 3, or I'm going to be distributing this 3. So 3 times 2x is 6x, and then you have x square with x square, so that gives you x to the power 4, and you already have a 3 here, another 3 gets multiplied, so 9. And now I'm quite confident you're able to look at the 4 option and choose your correct one. So this is not an answer, this is also not a correct answer, and I'm sure you're able to identify that D is the correct solution. So that completes your multiple choice question, which will help you for your AP Calculus AB exam. Let's try now some guided practice question. So we will be solving the A part first. Now here if you observe, the function gx is given as the quotient of 2 terms. So you have a numerator, you have a denominator. So when you are trying to find the first order derivative g prime of x, you are going to go for quotient rule. So derivative square x minus 1 as it is, d by dx of the numerator, negative sign 2x plus 1 as it is, and d by dx of x minus 1. So let's simplify. This will give you x minus 1. The derivative of 2 times x plus 1 is just 2. And here for the second term you have 2x plus 1 as it is and 1. So you have received now your g prime of x. Let's simplify. So this is 2x minus 2 minus 2x minus 1. So here you can see some cancellation happening. let me cancel with a different color. So 2x goes with 2x and you're just left with negative 3 times x minus 1 square. That's your first order derivative. Now that you've received your first order derivative, we also need to go for the differentiation one more time so that we can get the second order derivative now. So let me solve for second order derivative here. So to get second order derivative g double prime of x, we are going to differentiate again one more time our g prime of x. So that is going to be equal to d by dx of negative 3 over x minus 1 whole square. Now here I'm sure you are able to understand that negative 3 is a constant which can come out of the derivative. So we just have to differentiate d by dx of x minus 1 to the power minus 2. Now why I took the power on the numerator? Because I can simply just do now the derivative using power rule. So this will come down and you are left with x minus 1 times minus 3. So plus negative 3 and negative 2 will give you plus 6 and there is an x minus 1 to the power cube. So this is your final answer. So let me highlight the final things for you. So we have got our g prime of x, the first derivative, as negative 3 x minus 1 square. That's one part of your answer which works for the first derivative, and you have got your second derivative g prime of x as plus 6 divided by x minus 1 whole cube. So that completes the A part. B part I would want you to try yourself so that you can check your understanding. And one important tip that I would like to give you here is that for the B part you observe that the function sin x is there, so you have to go for trigonometric derivatives. I've already made a video on that, so please feel free to revise that video which was on trigonometric derivative before you solve this question. Now comes time for your practice to check your understanding. So try yourself these two questions as the homework for today's session. Feel free to put in your comments if you have any queries. You can check your answers by putting your answers for the two questions in the comment section. I will be happy to check it for you. That brings us to the summary of today's lesson. So in the lesson today we learned about higher order derivatives, and specifically we saw about questions based on your second order derivative. So the second derivative, as you have seen in the lesson today, is the derivative of the first derivative, and symbolically you can write it using this notation. Or if you want to describe in your own words, then you can say that the second derivative describes the rate of change of the function which is given to you. In other words, it is also described as the rate of change of the first derivative. Brings us to the end of today's session. I would urge you to revise the class, and we are going to be carrying on this discussion further about derivatives in our next video. So make sure you like, share and subscribe so that you can receive all notifications. Don't forget to press the bell icon for receiving all notifications about my upcoming videos. That is all from my side. See you in my next video. Bye bye.